Yeah, school's pretty cool today. At least we didn't do that physics project. I got it. Kidding, it's just me. Yeah, in this lab we're going to show the acceleration of two different kinds of tubes and sleds on a low friction surface. The purpose: what is the acceleration of a tube compared to the acceleration of a plastic sled on ice? Our simple problem then is to determine the accelerations of two different kinds of sleds. Hey Jeff, Pat!
For our lab, the control variables are the ice, tube, plastic sled, and a fixed distance. Manipulated variables are two different sleds, two trials on each sled, and two different people. Our hypothesis is we are guessing that the plastic sled will have a faster acceleration due to the less friction provided by the plastic material.
Do you think they'll drop the bomb?
Yeah, Ken! What are you doing in there?
I'm doing our project.
Yeah, well, I need to get my brush.
Homo?
You gay?
Trying to go poo. What a homo. Alright. The materials we need for this lab are one tube, one plastic sled, two stopwatches, and you need markers for the final distances. Procedure for this lab is measure out the initial running distance, measure distance of the slide of the ice, mark off the distances so that they are noticeable, have one person go 2 times in a tube and 2 times in a sled, time the initial running distance and the actual time of the slide on the ice, jot down this information on the data table for later calculations. Repeat steps 4 through 6 with a different person in the sleds.
Oh, cool. It didn't snow for our project. Guess we can't go sledding. Might as well just cut the grass instead.
Gee, I guess we'll try to go sledding on the pond. Might as well test the ice. Yeah, looks pretty safe. Yeah, pretty safe. Might as well do our physics project here.
Well, here we are at the experimental site. So far we've had pretty good luck. Only Ken has fallen in so far. This will be our starting initial distance. And here's our 2 sleds we'll be sledding with. And the sled rider will have a stopwatch in hand and take a time from second distance, which will be the initial time, to the distance there. final time. And right about there will be another person taking time.
Here we are back from the experimental site with our data table and all our calculations. First thing we had to calculate was our initial velocity, which was the distance times the time. Our distances were both 7 meters. Then we had to calculate our final velocity, which was done in the same way. Distance.
Cool.
At this point, we were able to figure out the purpose of our experiment. Jason's sled was faster than his tube, but my tube was faster than his sled. There's reason for this contradiction, however. When you look at the initial velocity, you'll see that his running speed was much faster than that of mine. So, in conclusion, we find that the initial velocity affects the end acceleration.
Time for the conclusion. In Jason's case, the sled was the fastest. In Jonathan's case, the Teenage Mutant Ninja Turtle tube was the fastest. When these two are compared, Jonathan's tube was the fastest out of all of them. The obvious factor that affects the experiment is that the initial velocities vary. A faster initial velocity results in a faster acceleration. As can be seen with Jason's trial and earlier experiments. Further experimentation could be the addition of an incline, where the initial velocity will be 0, and therefore the acceleration can be more accurately calculated. This ends our demonstration into an explanation of acceleration on a low friction surface.
Cool, it snowed after we did our project. Oh, I didn't think that would happen. Yeah, life's pretty cool.